Okay, today I'm going to be taking the Japanese aluminum foil ball challenge. So this is a challenge that I've seen floating around the internet these last few days. So I wanted to make one myself and see if I could actually make a solid ball of aluminum. And then I can test the density of it, and then finally I'm going to crush it in my hydraulic press and see if it crushes as though it's a solid block or a solid ball of aluminum. So let's go ahead and get one made. Okay, first let's get my ball. Okay, here's my aluminum ball. Now let's see if I can pound it down into a spherical shape first. Okay, we're getting there. This is already working better than I thought it would. It's looking pretty spherical, it's getting solid through the core, and it's getting actually shiny without even polishing it yet. Okay, now I'm just gonna sand this for a while with some water. Okay, now I'm using 1000 grit sandpaper. Then finally I'll polish it up. Okay, here's my final product, a shiny aluminum ball. This is awesome. It's just a shiny sphere of aluminum now. So what I want to do with it is I want to crush it in my hydraulic press, and I want to see if it crushes as though it were solid aluminum, or I can reduce the volume of it more with the hydraulic press. But before I do that, first let's test the density of it to check if it's as solid aluminum or not. Okay, first let's get the mass of it, then we'll get the volume of it and take the mass divided by the volume. That should be our density. Okay, we got 51 grams. Okay, now let's get our volume here. So our water line is right at 500 milliliters. Let's see how much it increases. It floats. So I'm pretty sure that's lighter than aluminum already. Okay, but let's still go ahead and measure the full volume here. Gotta get it all the way under the water. That's about an increase of 60 milliliters. Okay, so I measured my density to be around 51 grams divided by 60 milliliters, which is around 0.85 grams per milliliter. And the actual density of aluminum is 2.7 grams per milliliter. So this is a little less than half as dense as real aluminum. So this is kind of cool because it looks and feels like a solid metal ball, but it floats on water. It's really neat. So this is about half as dense as a solid ball of aluminum. Let's crush it now and see how small we can actually get it. Okay, Japanese aluminum foil ball in the hydraulic press. Man, I worked so long on this. I hate to crush it, but you gotta do what you gotta do. Okay, aluminum foil ball, 3, 2, 1. Crumbling apart. So that had a lot of room to keep getting flattened. Let's see what it looks like. So I should measure the density of it now, see if we got closer to solid aluminum. Okay, now to get the density of this, instead of just measuring the volume with water, since I have a flat circle here that is 7 centimeters in diameter and around 0.7 centimeters thick, just use pi r squared times the thickness and we get around 27 milliliters of volume here, and our weight was 51 grams. So we're at around 1.9 grams per milliliter. So that's a lot closer to solid aluminum. So it still has some empty space in there because we're not quite to the density of aluminum, but it's pretty darn close. It's feeling a lot more hefty now, a lot more solid, but you can see just how it flakes apart, that there's still some empty volume in there with just air in it. But this is what happens to a Japanese aluminum foil ball challenge in the hydraulic press. Hey everyone, thanks for watching another episode of the Action Lab. I hope you liked it. If you're not subscribed yet, hit the subscribe button, hit the bell to be notified of my latest videos out. And if you have any questions about this video or have any comments or suggestions for a future video, let me know in the comments section. Thanks for watching and I'll see you next time.